Okay, hello and welcome to my lecture series on microeconomics. So here's the lecture on production costs. So go ahead and begin. I'm going to talk about types of costs, production costs, and short run versus long run. So the important thing when we're thinking about production costs is this is one place in the course where we can get a lot of intuition directly from the basic definitions. So this is a place where we want to pay careful attention to what's the definitions of the costs that we're going to be developing here. Okay, so starting over, so production costs. When resources are used to produce something, all the other possible uses are foregone. This should sort of guide you to start thinking about opportunity costs, implicit costs, explicit costs, right? So if I use an hour, I can use an hour for teaching, I can use it for sleeping, playing video games. A single hour can only be used for one of those things. So we measure economic costs or costs involving opportunity costs by the value the resource has in its next best alternative use. I actually don't like that I said economic costs here. Economic costs include, you know, all the usual costs that we think about, plus opportunity costs, right? So, anyway, economic costs are incurred by the firm to attract resources away from their alternative productive opportunities. So these can be obvious, explicit costs, like the expenditure on labor or fuel or materials, and it can be non-obvious, implicit costs. So those that don't necessarily don't require a cash outlay. So this would be like the opportunity cost of using self-owned, self-employed resources, like the value of the entrepreneur's own time or something like that. All right, so the next thing we want to do is we want to think about how these costs matter for profits. So we define profit as total revenue minus total cost, and we could write profit as pi is equal to r minus c. So economists use pi for profits. Why? Because we use p for price, right? So um, typically I'll just write out profits there. But anyhow, so profit is just revenue minus cost. There's two ways of thinking of profit, right? So we said economic profit is total revenue minus total costs, which includes both explicit and explicit costs. So explicit costs are those that require a cash outlay, and implicit costs are like opportunity costs, things that don't require a cash outlay. Accounting profit is just regular total revenue minus explicit costs, and economic profit is going to also deduct implicit costs, right? So the big difference is accounting profit ignores opportunity costs and therefore could be misleading. Okay, so now we're going to get to the part where the definitions are really important. So we're going to think about defining variable costs and fixed costs. Then we'll define average variable cost, average fixed costs, and so on and so forth. Okay, so fixed costs are those that are invariant to output. This means it doesn't matter how much I produce, they're going to be this fixed costs stay the same. So this is things like the month's rent. So you think about the rent for a storefront. It doesn't matter how much they sell, how many units they sell, that rent is the same every month, fixed in the short run. We'll talk about short run and long run in a second. Variable costs are those that do change with output. So you can drive your variable costs down to zero by not using any ingredients, not using any inputs, not producing anything, right? So variable costs are those that change with output. So this is things like the price of inputs. So the variable cost of making cookies, for instance, would be the cost of flour, sugar, milk, eggs, and so on. And then total cost is the sum of fixed costs and variable costs. Okay, we can distinguish between short run and long run. So importantly, this doesn't have anything to do with time frames. So in a multiple choice exam, typical question is going to be asking, do you know the distinction between long run and short run? What's the difference between long run and short run? Well, in the short run, at least one cost is fixed. In the long run, all costs are variable. So if you have a situation where there's no fixed costs, you know it's got to be a long run analysis, right? So we consider it to be the short run if there's at least one fixed cost, typically capital, right? So like the rent example, that's referring to the capital the firm is using. It's a long run scenario if all costs are variable. If the firm is free to vary all factors of production, then we're in the long run. Okay, we think about average costs and marginal costs. Average cost is just cost divided by output. So average total cost is total cost divided by Q, output. Well, total cost is a sum of variable costs and fixed costs divided by quantity is average total cost. But I mean, this is a fraction with this is actually the sum of two fractions with a common denominator. So we can break this into two fractions, right? So variable cost divided by quantity, that has an interpretation. That's average variable cost. And fixed cost divided by quantity, that has an interpretation. That's average fixed costs, right? So, average total cost is going to be total cost divided by quantity. And the important thing is when you're learning the definition of average total cost and average variable cost, how do we get averages? Well, we divide by the number of objects we're considering. So to get average cost, we have to divide by output. It's cost per output, right? Okay, a couple things to pay attention to here. One is, what's going to happen to average fixed cost as output gets really big? Well, output, Q, is in the denominator. So think about this going, what if this is 1? What if output's 1? Well, then average fixed cost is just fixed cost. It's fixed cost divided by 1. What if quantity is like 1,000? It's a lot smaller number, right? What if it's 1,000,000, right? 10 to the 6th. So fixed cost divided by 1,000,000, that's small. As output gets really big, average fixed cost drives to 0, right? Doesn't quite reach it, but it approaches 0. Average variable cost, what happens as output gets big? Well, this is a little bit misleading how I wrote this, right? You're looking at this, you might initially think it does the same thing as fixed cost. No, actually variable cost is itself a function of quantity. So output is going to enter the numerator and the denominator. Turns out as output increases, average variable cost increases as well, typically. Okay, so we care a lot about marginal cost. Marginal cost is how total costs change when you produce one more unit of output. Right? So marginal cost is the contribution to total cost when you produce one more unit of output. Marginal cost is change in total cost per change in output. So if you want to think in calculus terms, this would be the first derivative of the total cost function with respect to output, with respect to Q. Right? Okay, there's an important relationship between marginal cost and average cost. This is another favorite multiple choice question. So if marginal cost is less than average total cost is decreasing. If marginal cost is bigger than average total cost is increasing. And marginal cost crosses the minimum of average total cost and average variable cost curves. Actually, this line that I said right here, this follows directly from what I said here. Right? As a consequence of 1 and 2, we get 3. So you're going to want to go back, think about this slide, and when I show you the pictures of these cost curves, and see how the interpretation of these two things gives us this. That's an important insight. I'll talk about the intuition for why this is true next, but that's important to keep straight. Okay, so whenever marginal cost is less than average total cost, we know average total cost is decreasing. When marginal cost is bigger than average total cost, we know average total cost is increasing. So why? Well, first I'll show you graphically, then I'll show you the intuition. I don't want to get ahead of myself, so I don't want to just go over the example. I'll show you the picture first. So, all right, whenever marginal cost is higher than average total cost is increasing, right? So marginal cost is above average total cost from this point here onward. So average total cost is increasing. Marginal cost is below average total cost to the left here. So average total cost is decreasing here, where marginal cost lies below average total cost. Just look at where the graph is. Look at where the line is. The line that represents marginal cost is below the line that represents average total cost over the portion where average total cost is decreasing. And the line that represents marginal cost is above average total cost over the portion where average total cost is increasing. And notice everything I said is also true for average variable cost. Okay? So let's go back to the statement. We know marginal cost is less than average total cost is decreasing. When marginal cost is bigger than average total cost, we know average total cost is increasing. That's exactly what's going on in this picture. Oops. That's exactly what's going on in this picture. When marginal cost is above average variable cost is increasing. When marginal cost lies below average variable cost is decreasing. Notice some other features here. Marginal cost, by a consequence of what I just said, has to cross average total cost from below at its minimum. Same thing, average variable cost. A couple other things to notice. Average variable cost and average total cost are going to move together as output gets big. Why? Well, average total cost is the sum of average variable cost plus average fixed cost, right? Average total cost is the sum of average variable cost plus average fixed cost, right? Well, the difference between average total cost and average variable cost is average fixed cost, which is going to zero as Q gets big. So the difference between these becomes less and less significant. They move together. Okay. And the other thing is average total cost is U-shaped. Average total cost is initially downsloping as the effect coming through the declining average fixed cost going to zero is the dominant factor. So the fact that we have declining average fixed costs, that for this portion, for the downward sloping portion of the average total cost curve, the fact that average fixed cost is going to zero as we're increasing output is dominating. And now that's becoming less and less significant as we produce more output. Now variable cost becomes more significant, and that's the upsloping portion. Okay. Here's another picture. I don't actually like this picture. These slopes are not great. But I should talk about this. All right, so if the total cost function is a cubic function, right, so like q to the third, then we're going to get quadratic average variable cost, because average variable cost is going to be total cost divided by q. So q to the third divided by q, we're going to cancel a q, so we're left with q squared. So that's quadratic, and we're going to get a quadratic marginal cost for a related reason. It's the derivative, right? Derivative of q to the third is 3q squared, so that's what's happening. But what do we need to know for our class? Well, there's a couple different shapes of cost curves. One, they can be curved like this really nicely, and that happens if there's a cubic total cost function, though I'm not going to quiz you on that. And if we have a quadratic total cost function, then we have straight lines for marginal cost and average variable cost. And average total cost is still U-shaped. Oh, the last thing I forgot to mention. So marginal cost is going to cross average variable cost at its minimum. And then here, again, marginal cost crosses average total cost at its minimum and average variable cost at its minimum. Right? That happens here as well. And then average variable cost and average total cost move together. So what's the important thing? Well, there's a couple different shapes of cost curves we can see, this one or the other one, and you want to be able to recognize what's the commonalities between them. Well, I just mentioned them. So we have marginal cost crosses average total cost and average variable cost at their minimums. Average total cost is U-shaped, and marginal cost, or average total cost and average variable cost move together as output increases. Right, as Q gets really large, as we move to the right. All right, so to understand, here's the example to illustrate marginal cost and average total cost. Think about like batting averages or GPA, right? So average total cost would be like the player's season batting average. Marginal total cost would be the contribution to batting average in a particular game. So if you have a game where your average is higher than your season average, it's going to drive up your average. If you have a game where your season is less than your season average, it's going to drive down your average. Same thing with like GPA. If you have a semester where your GPA is higher than your cumulative GPA, it'll raise your GPA. If you have a semester where your grade point average is lower than your cumulative grade point average, it'll bring it down. Same sort of thing with average total cost and marginal cost. Okay, so next part of these slides are talking about production functions and marginal product, and I don't want to spend a whole lot of time talking about this. the basic thing is we have a firm that's going to take labor and capital and turn them into outputs. So we're going to have some input of labor, some input of capital. It's going to have some production process, and it's going to kick out output that's going to sell. Um, so this portion from the end of cost going into marginal product, this is interesting. I'll say some things about it. The reason why I put it in the slides and the reason why we care about it is because this is where cost curves come from. Cost curves come from the production technology that the firm has, right? How efficient is the firm? How many inputs does it use to make outputs? How much those inputs cost? These all drive the construction of cost curves. So where do cost curves come from? Well, it comes from the production process. And there's actually a mathematical relationship, and it's not difficult, but it's difficult enough where I'm not going to make it something that we're going to talk about here. Other classes very well might, but okay. So we need some additional terminology to build to profit maximization. Total product is the total amount of quantity of a particular good or service produced. Marginal product is, what's marginal reasoning? Marginal is the additional contribution to total production when you use one more unit of input. Average product is the output per unit of input. So marginal product would be the change in total product divided by change in input. Average product would be the total product divided by units of input. So in this case, I'm saying labor. Okay, and you get this nice relationship between marginal product and average product that looks a lot like our cost curves. Well, it's because the average product and marginal product and production functions are going to give rise to it anyway. So, all right, I'm gonna actually skip over this even for the purpose of the video. I skipped over this in class, so I'm gonna skip over this here as well. Um, you know, all right. So, production costs in the long run. The idea is like in the long run, the firm is able to vary all of its inputs. So it's able to figure out what's going to be the lowest cost production scheme. It's going to find what's the efficient scale. How should it operate? So the short run average total cost curve was simply a single U-shaped curve. The long run average total cost curve is actually, it nests all the possible short run average total cost curves, one for every possible size of the operation. Basically, the idea is the firm is able to choose which short run cost curve it wants to be on. So you have a whole bunch of different short run cost curves, and then the long run average cost curve is just the minimums of these. So I didn't draw my picture great, but the basic idea is that in the long run, so one of these we were seeing before, our average total cost curve was a short run concept. And basically what the firm's doing is going to select its optimal size of factory to be able to operate efficiently. And so the long run average cost curve is going to nest all these different possibilities. Why do we care about this? I'm not going to show you this graph again. The important part is in the long run, the firm is free to vary all of its inputs, and the consequence of that is in the long run, the firm is able to choose which cost curve it's on. And I realize I'm shaking my monitor, so sorry about that. All right. So the downsloping portion of long run average cost corresponds to economies of scale. So economies of scale happen where if you increase the size of the operation, you're going to lower the average cost of production. So this is like it's like a car factory. So if you want to produce cars, it's the average cost of production fall if you increase your output substantially. Why? Well, you can take advantage of the assembly line and different sorts of things like that. The upward sloping portion of long run average cost corresponds to diseconomies of scale. So this would be where increasing the size of the operation leads to higher average cost of production. So where would that happen? Well, suppose you're making something where it requires the individual's personal touch, or you think of a situation where you've got a bakery and whatever is your recipes don't scale up very well. Maybe you lose the sort of homemade freshness if you're when you're producing on a larger scale than a smaller scale. I don't know. You could tell a variety of different stories. For diseconomies of scale, there's other sorts of things. I mean, you might argue that there's diseconomies of scale to education, right? So that's actually, so you think about the cost of education. Interestingly, costs in a lot of industries have fallen. Costs in education haven't fallen in the same way that it has in a lot of other industries. And so, one story could be there's certain diseconomies of scale. Not everywhere, but certainly there's some diseconomies of scale. So, okay, scale economies. The downward sloping corresponds to economies of scale. The upward sloping corresponds to diseconomies of scale. What would I ask on an exam? I'd ask about economies of scale. So economies of scale would be like Costco, right? So, and then, or car production. So a warehouse supermarket like Costco buys a lot of food in bulk, and this lowers average cost. So the delivery of like 50 gallons of milk has a much higher average cost than if you deliver 5,000 gallons of milk, right? And then the factory, there's benefits through using an assembly line. You could take advantage of specialization. And if you're going to bother to separate out all the stages of production, better be a case you've got large output, right? Otherwise, it's going to be really inefficient. All right, constant returns to scale. So if the long-run average cost curve didn't change, no matter what was our size of operation, that'd be constant returns to scale. So, okay. Next thing is economies of scope. There's kind of two interpretations of economies of scope. The one that most people will give you, probably most classes and most books talk about economies of scope. They'll think about a situation where a firm is able to lower its costs by taking advantage of doing several different activities, by taking advantage of the same organizational structure, access to capital, marketing, facilities for production, distribution chain, so on and so forth, supply chain. So that's the common sort of story of economies of scope. If you have a lot of related industries, but they're produced by one single firm instead of several separate ones, they can benefit from all the things from having a single organizational structure, essentially. The interpretation I like better is the iPads, iPods, iPhone story, or the Cheerio stories. So the idea is it's cheaper for one company to make iPads when they're already producing iPods. So Apple. So Apple makes the iPod. After having made the iPod, it was cheaper for them to make a smartphone, the iPhone, than it might have been for two separate companies to have an MP3 player and a smartphone, right? And then conditional on already making those two products, it's cheaper to be able to make the tablet than it would be for three separate companies to make smartphone, MP3 player, and tablet, right? So that's the idea. And then the Cheerios example, right? So if you're already making regular Cheerios, it's cheaper to make Honey Nut Cheerios and Apple Cinnamon Cheerios and all the different multigrain, right, than to have four separate companies, right? So, okay. So that's economies of scope. Cost savings when you're producing kind of related things. Okay, cool. All right, so we'll go ahead and conclude here.